Hello, everybody. It's Jason Nemro, and I'm fighting back from a struggle. Sometimes I get a presentation ready and I get ready to record it. I only give myself 10 minutes. I think that's a good solid line. You know, if something takes longer than 10 minutes, it's probably too long for modern things. And sometimes the subject ends up. If I try to make a recording that's consistently more than 10 minutes and I can't cover the whole thing, got to split in half. So you're getting a split in half one. The first half is called hardware, and that's a little too nebulous. So we're going to take care of the hardware stuff first so that you understand what's going on and how things work. And then we'll talk about the second half of this later. You'll see some more things over here. This will be the subject of a subsequent video. So hang in there. Okay, first, the thing you want to learn from this particular recording is that every computer is basically the same. Every computer has the same basic parts. So when I'm talking about computer, I mean any kind of computing device. This can go from we always talk about toasters, you know, and you go, oh, you got a computerized toaster. And you go, well, that doesn't take a whole lot of brains to it to come up with a toaster. I mean, we used to do it all mechanically, and that's true. It is cheaper, though, to have a computer take care of some of those functions instead of having a mechanical piece of equipment do it. It tends to be less expensive to rig the thing with a really cheap microcontroller and some software than it would be to try to do the engineering needed to have hardware do it. Sad part is the way things are built now, sadly, we're always trying to score for cheaper and cheaper and cheaper and cheaper. And sometimes the manufacturing processes are bad. Sometimes we really have some inattentive processes, talking people, putting this stuff together so you can have a high failure rate. And with the mechanical stuff, sometimes you solve some of that by just not giving it so many failure points. Sorry, it comes from a management standpoint. Also, you guys know me, I'm kind of a throwback and anachronism. And sometimes hardware, just straight mechanical, ends up being either reliable enough that you don't want to re-engineer and try to put a microprocessor into something, or it's just more reliable from a manufacturing standpoint. Our ability to standardize mechanical parts seems to be more established than electronics. In most cases, we don't care. We put electronics through a system. It can be manufactured quickly and cheaply by cheap labor. And if you don't do good quality control at the other end to make sure every part's working, there's going to be a failure rate. Get into that. And that's totally from a management standpoint of which direction you want to go in. So whether it's a toaster, whether it's a refrigerator, whether it's a desktop computer or a printer, it's kind of all the same. They all have these same kinds of parts in it. Sometimes they're combined into a single, something that looks just like one part, but it'll contain all kinds of different things in it. It's what's called integration. When you hear the term IC, integrated circuit, perhaps, you have to understand that it includes a whole lot of little bitty bits. They all used to be separate little things, resistors or capacitors or diodes. They've all been shoved into one little piece of silicon. You've seen the square or the rectangular chips. Those are called integrated circuits because they often have a whole bunch of little parts in it. And you can see in many cases, it includes all these different pieces that we might be talking about. Number one is compute. This is what most people think about when they think about a computer. It's got what's called a central processing unit. Um, there's a whole bunch of little pieces put together, and it basically does most of the computations that need to be done. If you need something to make a choice to get some input, and based on that input provide a certain kind of output, which is what computers basically do. That's what your central processing unit's there for. Every central processing unit needs some memory to hold information it's trying to work with. And a lot of the input-output, which I'm talking about now, is all about taking stuff from an input, sticking it in memory until the compute can do its calculations on it, sticking it back in memory so they can go to an output port. This usually happens so fast and goes so well, and usually so seamlessly that we don't even think about it as anything different. When you're recording a video, there's a huge amount of processing going on in the background that you really don't know about. And it all happens in this compute phase. Then, of course, when you guys went through the tour and you looked at the hardware, we pointed out some different parts on it. But the things that probably showed up the most was store and I/O. Anyway, in storage, we already talked about the secondary storage devices that you have on your computer. These are the things that are preserves your data through a power outage, whether it's intentional or not, or things that have to be more permanent. And they're broken down into a couple of pieces these days. The magnetic storage, which you're all accustomed to, hard drives, magnetic, optical, which you know as DVDs and CD-ROMs, things that are really good for switching in and out when you need certain information at one point, but you don't need it at others. Like when you're playing a game, you want to put in all the data that the game needs. And then at other times when you don't want to play the game and you want to do some other function, you take it back out and put in another CD or DVD. And of course, solid state is a whole nother way of doing it. It's just become practical. We've had solid state memory was actually the first memory that we ever had. It was just so expensive. It's finally getting down to the price point where a lot of people can use it. Like actually in their desktops or in a server, it makes sense now to use some solid state for a couple of reasons. Anyway, I don't have time to talk about that. All right. And then you've got the network piece, compute, store, network. This is how you get your information in and out and share it with other people or share it with other jobs, other applications. And I could talk all about marketing all day long because a lot of these terms have just simply fallen into just being marketing terms. Wi-Fi is usually used as a generic term for any kind of wireless delivery system. It wasn't originally that way. It's actually a particular specification, although now nobody actually uses that specification anymore. Although the term Wi-Fi is really kind of hung on. Ethernet is a certain way of handling network transmission and conflicts. There's a big thing about conflicts there. You don't really need to know about that now. We found out there's one way that just seems to work well enough for everybody, and everybody uses Ethernet. Of course, the actual transmission media, which is where fiber optic comes in. We do have copper still, and we have fiber optic. Those are really the two predominant ones, and probably the two that really make any sense. And there's good and bad sides to using one or the other. Fiber optic, of course, faster. It's more expensive, and it's got some nice attributes. You don't have to worry about things like crosstalk with fiber optic. Anyway, so every computer is basically the same. Don't forget that. It's fantastic. Now we'll go on to the second part as soon as you're ready.